Calculus, Unit 7, Day 63, Part 4. If the axis of rotation is the y-axis or is parallel to the y-axis, the integrand needs to be in terms of y, and the limits of integration need to be the y values of the points of intersection of the curves that form the region being rotated. So this is just like what we did the previous um, practice problems, except now we need everything in terms of x equals, and we're now looking at it from the y values. So consider the region pictured to the right that is bounded by the graphs y equals plus or minus square root of x, and y equals x minus 2. Find the volume when the region is rotated about the y-axis. So the first thing I have here is this is my y equals positive square root of x, this is y equals negative square root of x, and this is my line y equals x minus 2. Well, I need to solve this for x, so this becomes x equals y squared, or y squared equals x. Here I add 2 to each side, x equals y plus 2. So when I'm looking at it for the y-axis, right here, our outer function is still going to, and we're going to look at it here, but our outer function is still going to be the one furthest away from our axis of revolution or axis of rotation. So that's going to be the line. So let's set this up. And again, my y values, I'm going from -1 to 2. So let me pause and we'll set this up. Okay, so the y plus 2 is the line, that's the furthest one away, minus 0, because we always subtract whatever the axis of revolution is. And y squared is the parabola, that's the closest one to it. And minus 0, again, the axis of rotation or revolution, either way. And squared, because it's pi r squared. And this is the outer radius, this is the inner radius, you take the difference of those two. And then this is the height, the dy. Okay, so now let's simplify this. And now we're going to go through and take the antiderivative, undoing the power rule, and then use the fundamental theorem of calculus to find out what it is from -1 to 2. Okay, so the same thing we've been doing, put in, you take the antiderivative, so that's the calculus part, and then you substitute it, and I just put the answer down, but you can make sure you check that. Okay, and now let's do these last two, so let's do one at a time. So this is when the axis of rotation is x equals 4, which is right here, which now moves the x equals y squared as my outer function and the line as my inner function. Okay, so obviously that has an impact. Let me set it up. Okay, and it's always the outer function minus the axis of rotation minus the inner function, and that's squared, minus the inner function minus the axis of rotation, all squared. So there's your pi, there's the radius squared, and there's your height, the dy. Okay, and you work on that, but you should end up getting 108 pi over 5. Okay, so it's just the rest, 2 steps of algebra, and then a step of the fundamental theorem of calculus. So again, 108 pi over 5, and we'll do the steps out on the last one. So again, it's the outer function, which when we're at x equals 7, which is a vertical line, the outer function is once again the sideways parabola, x equals y squared. And the inner function is the line, which x equals y plus 2. So now we just need, the next couple steps are just multiplying these out, and then simplifying, and then once we get it to a simplified integral, then we can take the antiderivative. So let's do that. So we go through and square this one, combine like terms, and now I can take the antiderivative, which will give me volume equals pi is a constant that just stays here. So this is y to the 5th over 5 minus 15y cubed over 3, which is just 5y cubed, 10y squared over 2, which is just going to be 5y squared, and then plus 24y. And we're going to evaluate that from -1 to 2. So that's the fundamental theorem of calculus. So let's do that. So this is what we get when we put in the 2, and you'll notice we're getting a lot of fractions, obviously. So just add another step. Let's keep going. So we get, we're subtracting the quantity, negative 1/5 plus 5, and that's a minus 24. Sorry about that. So let's combine all the 32 fifths plus 1/5, which will be 33 fifths. So times pi, and then the negative 40 plus 20 is negative 20, plus 48 is 28, 10 and 10, 38 minus 24. Does that make sense? Let me check that. Oh yeah, so it's over here's 28, over here's negative 14, but it's 28 minus the negative 14, which would be plus 14, so plus 42, which will be 33 fifths plus 210 fifths, which will end up being, so our volume of this shape rotated around x equals 7 for the axis of rotation is 243 fifths pi. Okay, and we can do that for any shape. Now obviously if they change which one's the outer function, which one's the inner function, we just have to do this multiple times. So we just got to pay attention to, is the outer function always the same? Does it change? If so, where? What are we rotating around? A horizontal line or a vertical line? But every other step is exactly the same. Okay? So that's how we do volumes of solids of revolution.